Morello Platform Model and Android Stack Walkthrough. So this video provides an overview of setting up a Morello Development environment for Android. This tutorial will guide you how to install the Morello Fixed Virtual Platform, build and run a capability-enabled software stack, and finally run some workload tests. Open a terminal and create the Morello Workspace folder, where we'll place all the files we'll need for this presentation. Also, create a folder named Model, where we'll install the model. Now, open a web browser and go to morello-project.org. That is the Morello landing page, gathering all the information we'll need. First, let's download the FVP by going to the Ecosystem FVP developer page and download the Morello Tabo. Go to Morello FVP and click on Download Linux. Once the download has finished, copy the tabo to the model folder and extract it using tar-xzf fvp-morello.tgz. As you can see, it contains an installation script and the license term folder. Please read these licenses before sharing the downloaded file. Now run the installer and type yes to proceed. The end user license agreement will be displayed. Read it carefully and scroll down by holding enter. Once you've read all the license, agree to the terms, otherwise the FVP will not be installed. Point the installation to Morello_workspace model FVP_Morello. Make sure you have the correct path. Type yes or enter to create the folder and proceed with the installation. As you can see, the FVP Morello folder has been created and populated with all the required files to run the Morello FVP. Go to the installation folder and type 3 dot to see all the installed files and dependencies. If you need more information on how to use the FVP, read the Morello reference guide PDF under the doc folder. Type LDD and the model path to check that all the required dependencies are installed and correctly linking to your FVP, like the one you see here on the screen. Check that you have the correct revision shown on the rev file. Otherwise, you can also run the model without with the -- version parameter. Check that it prints the version 0.11.3. Now run the model without any parameter to verify that you will correctly link dependencies and run the model without causing a segmentation fault. The dashboard and the LCD will pop up in GUI mode. However, if you'd prefer, the FVP can also run in the console mode. Note on the dashboard that the SCP and MCP have been powered on but are not running any instruction. Therefore, some warnings will be shown on the console. Run the model with the -l parameter to list all of the input parameters the FVP supports. If you still have doubts about the installation and how to use the Morello Platform model, please read through the reference guide under the doc folder. Now, let's build the Android software stack to run on the model. Go back to the Morello project landing page on your browser and click on the Morello code repository link. This will take you to the GitLab repository containing the open source software stack. Go to Documentation, then go to User Guide, Before we start, make sure your PC meets the prerequisites for building the software stack. Your PC must have Ubuntu 18.04 and at least 250 GB of free storage space. The first step here is to update the system and install the required dependencies. Copy and paste these two instructions onto your terminal. First, the apt-get update command. At the end, check the errors list as won't impact your build, but if they do, fix them. Once they're fixed, let's proceed to installing the required dependencies by copying the second command and pasting onto the terminal. As you can see, all the dependencies were installed and at the newest version. Now that the PC is ready, we can clone the repository, configure the build variables, and finally build the Android software stack. So scroll down to the Android stack section and follow the instructions there. Copy and paste each command individually onto your terminal. First, copy and paste the repo init command that will initialize the repository. Then, copy and paste the repo sync instruction to start the initial download of the required files to allow building the software stack. This task can take a bit of time because it depends on your internet connection. You can pause the video here and continue once this is finished. I'll fast forward to the end so we can proceed with the following steps. Then go to the BSP folder to set up the build environment variables and build the firmware. Copy these two lines and paste it onto the terminal. This step will configure and run Bitbake to download and build the SCP, EDK2 firmwares and the group bootloader. The MCP and SCP firmwares are needed to initialize the platform and prepare the application processor to initially run group and then the Android software stack. On completion, go to the Android folder, which is 2 levels up, and build the Android image as shown on the instructions. Do this by copying and pasting the build command to your terminals, as shown on the browser. This procedure will then start building the Android Nano image to run on the Morello Platform model. It will also gather all the binaries and images in a single folder to make it easier for us to find them. As you can see, the final Android image is around 4.5 gigabytes. For more information about the Bitbake recipes, go to BSP Layers Meta-ARM folder. The intermediate images are under Android output. Do a tree command there to see the generated files. These are the images that will be executed by the model. Lucky for us, the build script has already copied these images to the target folder that will be used by the run model script. Locate them by typing ls .bsp build pokey tmp pokey deploy images and then Morello FEP. And find all of the software stack files together under a single folder. So these files listed here on the terminal is what we need to run on the model. If you need more information about them, read through the sections listed on the page. Now let's run the model with the Android software stack. Scroll down to the section running the software on FEP. Go to the Morello workspace folder and check that the run scripts folder is listed. Then copy and paste the run model script command with a -m parameter pointing to the model executable located under model/fep morello /models/linux64 gcc 6.4/fep morello and add the -f Android parameter. Here we use GUI mode, but console mode is also supported and can reduce graphical latency to improve FEP performance, especially if you're running it remotely on a server. At startup, the dashboard and LCD will pop up along with 4 other terminals, the SCP, the MCP, and 2 application processor UART terminals. Note that we only need 1 application processor terminal acting as the command line console. The SCP starts running the firmware to initialize the platform and make the application processor ready to run the group bootloader to boot Android. Once group lists Android on the FEP terminal, hit enter, it will soon start booting Android. Note on the dashboard that we can see that the application processors composed of 2 clusters with 2 cores each have been detected and are running. As you can see, Android is booting, and this process can take up to 5 minutes to finish. This is the MCP UART terminal. This is the second AP UART terminal, which is inactive. This is the first AP UART terminal that allows the user to interact with Android, and this is the SCP terminal. The LCD panel for displaying any graphics, and finally the dashboard giving us a visual feedback of the FEP status. It displays the SCP, the MCP, and the application processor statuses, like frequency that has been set up, the number of executed instructions. It also has a reset button to restart the FEP without the need to relaunch the model from the host console. Now we wait until the boot process is finished. Look at the AP UART terminal that Android is initializing services, loading drivers and modules, as well as mounting the file system. Once the boot process has finished, the console can be handled by the user. We can then try some typical shell commands to interact with Android. Try ls a couple of times. Try ifconfig to see the network interfaces. Let's try that again to see that the network interface has been set up. Type nproc to check the number of detected CPU cores. The message to print the system initialization messages. Get familiar with the FEP by trying different commands, as well as ls a couple of times to see what's on the file system. Also, list the device drivers under the dev folder. And there we have it, a capability-enabled Android software stack running on the Morello FEP. Now that we have Android running, let's run the Android debug bridge to connect to the FEP shell or even send files to the FEP. This is useful if you like to transfer an application to run on the model. So in your browser, scroll down to the section running Android debug bridge with FEP and follow the instructions. Make sure you have ADB installed and attached to the FEP model via port 55 using the following command: adb connect 127.0.0.1:555. So you can see that our device is connected, and now we can connect to its shell by doing adb -s, the localhost IP, and shell. You can see when we hit enter, it will go directly to the shell, and we have the same folder structure when we do list. Now try echoing a message to the terminal on the UART terminal that's on the background. Let's echo testing 2/dev ttys0, I believe. Let's check on the terminal. It's not there. Oh yeah, so it's not S0, it's AMA0. So try that. As you can see, the message got printed out on the UART terminal. So we are on the right FEP. Let me just exit that and prepare to send some workload tests to run on the FEP. Now let's run some workload tests. On your browser, click on the workloads link and follow the instructions. First, cd to the Android folder under the Morello workspace, then sets up the environment variables by copying and pasting the instructions on your terminal. You can then build a test by typing m followed by the name of the test and send it to the FEP via ADB push. So I'm going to start doing the Bionic test by first compiling the Bionic unit test static, which will generate the A64 plus the C64 test suites. Now I'm going to push the A64 test suite to the Morello FEP that's running on the background. And then I'm going to push the C64 Bionic unit tests again. So first the A64 and then the C64. C64 contains the capability enabled software tests that will allow exercising the capabilities of features that Morello FEP embeds. Now go to your FVP console terminal, where we can use the instructions below to run on the model. So first, like I said, the A64 test, we copy and paste onto the terminal, FVP terminal, and press enter. As you can see, there are around 2700 tests from 139 test suites. This can take up quite some time because there are loads of them, and this is running on a fixed virtual platform, so it can take some time. You see that there are some warnings, nothing to worry about, but you can see that there are multiple tests being run and passing the test with the showing on the OK flag. So I'm not going to wait for all of these tests during this presentation. I will skim it through in a second. But just to let you see that it's a complex number of tests being run on the Morello FVP model. So after some time it's still running. And lastly, it will go to the end. Almost finished now, and in a second I'll be running the C64 bionic tests, which are similar to these A64. But like I explained, C64, they exercise the capability features that Morello embeds. Okay, so the A64 test finished. As you can see, there are loads of these tests showing up, and we had 13 slow tests. Now let's run the C64 bionic unit test static. Just copy and paste onto your FVP terminal and hit enter. And they should start running anytime soon. There it is, around 2700 tests as well from 137 test suites. Now we wait until each of these tests gets get executed by the FVP, and as you can see, they're being run and the OK flag saying that they've passed. So we'll wait for a little bit more time so we can see that they have finished. So I just skimmed to halfway through the test, and as you can see, all of them have passed until now, and they keep on going. Now it's doing some semaphore tests, set jump, smoke test, and just a little longer to see if anything will break. So let me fast forward a little bit. Now it's doing the mem move check. Wouldn't surprise me because this is quite intensive and does exercise a lot of the capabilities features, in particular with the using memory. So let's see just what it's doing. And skim it to a little bit longer. It passed most of the tests, oh, all of the tests actually. And let me go to the end. There you have it. So it did execute everything without any problem, just some information, everything run okay, but we did have like 15 slow tests. I believe this is because of the platform that's being virtualized, so that should be fine. And now I finish my presentation and hope you guys can continue on working on the Morello FEP, building your own applications and running on it. Thank you.